Let's look at some problems involving compound interest now, and we're just going to start with a very standard one. What is the value of investment of $5,000 invested over 5 years at 3% compound interest per year, compounded annually? So this is compound interest, so that tells us that we're going to need our compound interest formula. So A equals P times 1 plus R over N to the power of N times T. Principal, the amount of the initial investment is $5,000, so we're going to set P equal to 5,000. 1 plus, so we have R is the rate of interest as a decimal, so we have 3%, so that's going to be 0.03. N is the number of compounding periods. So we're told that this is compounded annually. So that tells us that it's compounded one time per year. So n is going to be equal to 1. And that's raised to the power of n times t. So n is again 1. T is the time in years, which is 5. Now, you're going to be doing this on a calculator. I highly recommend that you get in the practice of putting brackets here, just to remind yourself when you type this into a calculator to not leave those brackets out. So I worked this out separately on a scientific calculator. I ended up with a value of $5,796.37. If you can think back, these are the exact same numbers that I used for the simple interest problem back in 1.1. And that ended up being, I believe, 5,750. So this did earn a little bit more interest over a 5-year period because the interest kept getting reapplied to the principal every year when the new interest was calculated. I just want to write down here that if you're doing this on a TI or a scientific calculator, this calculation is very important to type in accurately. It's going to look something like this. 5,000 times 1 plus 0.03 over 1 raised to the power of 1 times 5. Important things to note here. These brackets are critical to tell it that it's raising 1 times 5 to the exponent and not just the 1. These brackets are, of course, critical. This is the caret symbol on your calculator, and it's used to show that you're raising something to the exponent. So if you're typing this into a calculator, especially a TI, this is probably what it's going to look like. And this is where your answer of $5,796.37 will come from. Rounded to 2 decimal places because we're dealing with money. Before you go on to the next slide, I would make sure that you pause this and evaluate it on your calculator to ensure that you get the same answer that I did. Question number 2. We have Bill who invests $6,000 into a GIC, earns 3.2% compound interest. So this is right away an indication that we're going to use our compound interest formula. It's compounded monthly for a term of 5 years. Part A, how much money will Bill receive from the GIC in 5 years? So let's use our compound interest formula. P times 1 plus R over N to the power of NT. And again, we'll start subbing in the values that we know. So the initial investment was $6,000. R, so this is 3.2%, so R is going to be 0.032. So we can take that 3.2% and divide it by 100. Now we need N. This is compounded monthly. There are 12 months in a year, so N is 12. And raising this to an exponent, this will be 12 times the number of years, which is 5. I use 12 there, of course, because there's an N in the exponent. And you may want to include brackets here just so you ensure that you do not forget them when you're putting it into your calculator. In my calculator, I evaluated this to $7,039.57. This ended up being a 0.565, so I rounded this value up. Part B, how much interest will Bill have earned? Well, we can't use I equals PRT because that only applies for simple interest. However, we do know that we ended up with $7,039.57, and the initial investment was for $6,000. So the difference between these two has to be the amount of money that we earned, which was $1,039.57. Question 3. So we have at age 40, Grace invests $1,500 into an investment, which earns 4% interest compounded semi-annually. How much will Grace's investment be worth when she turns 60? So this is compounded semi-annually. So the moment we see that word compounded, we know we're dealing with compound interest. So A equals P times 1 plus R over N to the power of NT. Let's fill in what we know. The initial investment, the principal, $1,500. R is the rate of interest, so 4%. We're going to use 0.04. N is the number of times that this investment is compounded every year. So this is compounded semi-annually. Semi-annually tells us that it's compounded twice per year. So N is equal to 2. And T is the time in years that this is compounded for. Well, it starts when Grace is 40, and it ends when Grace is 60. So the difference between those two is 20. That tells us that's the number of years that this investment is going to be compounded for. So 2 times 20. And again, we can work this out in a scientific calculator. I did that and discovered that this investment, after 20 years, will grow to $3,312.06. All right, final problem. And this involves estimation. So we have Anita invests $3,000 into a Canada savings bond, earns 6% compounded annually. We want to estimate the amount of time it will take for this investment to double. So this is compounded annually, and we want to figure out how long it's going to take to double. So that means that we should use the rule of 72 in order to estimate the doubling time. Our investment earns 6% interest, so we're going to take 72 and divide it by 6. 72 divided by 6 is 12. So the estimate is it should take 12 years for this investment to double its value. Realize, however, that this is just an estimate. And this estimate does work best when the investment is compounded annually. It's not necessarily exactly precise, but it should be close, particularly for annual investments. Part B asks us to calculate how much money Anita's Canada Savings Bond will actually be worth after that amount of time. So after 12 years, what is the value of these Canada Savings Bonds? How close is it to our estimate? Well, the investment was $3,000. For 6% interest, so 0.06, our N is 1 because this is compounded annually, and we estimated that this should double after 12 years. Does it double after 12 years? The actual value, $6,036.59. Pretty close. Only off by $36. And when you can see that we're dealing with thousands of dollars, this gives us a quick estimate of roughly how long it will take for this investment to double. Now, you wouldn't use this for when precise calculations are needed, but if you just need to guess how long it'll take something to double, you can see that this comes up with quite an accurate estimate.